Hello everyone, welcome back to Infinity Physics. In this lecture, we are going to discuss the derivation of the magnification formula for the lens. In the lecture number 6, we have discussed the derivation of the magnification formula for the mirrors, and in that I have discussed the details and the concept of magnification. So if you want to know the concept of magnification, then you watch that lecture number 6 in this playlist. In this, I will only discuss the derivation of the magnification for the lens. So, here we have a convex lens having here focal length f, and here it is radius of curvature, or we can say center of curvature. The object is placed beyond the center of curvature or beyond 2f, and its real and inverted image is obtained between f1 and 2f1 on the other side of the lens. This is the case number 2. We can derive the same equation in all the cases of the lens. Either it is a convex or a concave lens. So, what is the meaning of magnification? What is the definition of magnification? It is the ratio of the height of the image to the height of the object. So, here we have object whose height is HO or AB, and here we have image. It is the object, and here we have image whose height is HI, or we can say A dash B dash. And now we want to find the another formula relating image distance and object distance. So here we have object distance, which is u, and image distance, which is v, right? So in the derivation of the lens formula, we have obtained that this triangle, which triangle A dash, or we can say this triangle A dash, B dash and O. This triangle and triangle ABO, these two triangles are similar, because here these two angles are opposite angle. This angle is a 90-degree. So if two angles are similar, then all three angles are similar and the triangles are similar. So we can say that the right angle triangle A dash B dash O and triangle ABO are similar. So if we take the ratios of their height and the ratios of their sides, then the ratios are same. For example, here we have A dash B dash. It is the height of the one triangle divided by the height of the another triangle AB is equals to the base, ratio of the base. So here OB dash is the base of this triangle and OB is the base of this triangle towards the left side. We know that here in the given picture, A dash B dash is the height of the image, but it is towards the we can say it is below the principal axis, so it is minus HI. And here we have AB, which is height of the object, which is plus because it is above the principal axis, is equals to OB dash. What is OB dash? This distance, which is towards the right side. So it is image distance V, and it is plus because it is towards the right side. And here OB. So OB is towards the left side, which is object distance. So we can write it is minus U. So if I take this towards this minus sign towards right side, then we have HI by HO is equals to minus V by minus U. Now minus minus plus, and here we have M is equals to HI by HO, where M is the magnification. So HI by HO is a magnification. So M is equals to V by U. So this is the formula of magnification for the lens in terms of image distance and object distance, and this is the general magnification formula relating the height of the image and height of the object. Same formula for the mirror can be written as M is equals to minus V by U, where V is the image distance and U is the object distance. If the magnification is negative, then the image is real and inverted. If the magnification is positive, then the image is virtual and erect. In case of the concave lens, you will always get the virtual and diminished image. Virtual, erect and diminished image in case of the concave lens. So the magnification by the concave lens is always positive. Is always positive and it is always less than 1, because in case of the concave lens I have discussed that for all the position of the object from infinity to the origin, in all the position the image is always smaller than the height of the object. Suppose this is our concave lens. So if you place object anywhere, you will always get image between optical center and focus, and which is always smaller, virtual and erect. So here magnification is positive because the image is virtual and erect, and it is less than 1, right, between 0 and 1. So the magnification is smaller than 1. Now in the next lecture, we will discuss all the numericals related to lens